function from its zeros. So we're going to form a polynomial of degree 3 whose zeros are -4, -2, and 3. So this is telling me that x equals -4 is a 0. What factor creates it? If you have x equals -4, what's the factor that creates it? Yeah, the factor is x plus 4. That's really all there is to forming polynomials. Not a whole lot more. So this thing's going to be of degree 3, whose zeros are -4, -2, and 3. One of our factors is x plus 4. One of our zeros is x equals -2. What's the factor that creates that thing? X plus 2. I heard it nice and silent. And the last zero is 3. What's the factor that creates x equals 3? X minus 3. Now, we're going to go ahead and we're going to say with a equal -2. You need to put a coefficient in front of there. So that little guy is going to drop right there. And here is our polynomial in factored form, which was cool when you were in Algebra 2. You're not. You're in pre-calc. We're going to put this in standard form. Which is not hard. How might you put that thing in standard form? Don't worry about that -2, by the way. You can worry about it last. I wouldn't worry about it in the beginning. How can you put that in standard form? What would Jesus do? He'd FOIL. Pick on 2 of those factors and FOIL them. If you want to work with the front 2, that's fine. If you want to work with the back 2, that's fine. Pick on 2 of them and FOIL. I'll pick on the front 2. X times x is x squared, plus 2x, plus 4 more, plus 8. And then you got that x minus 3. What can you still keep doing? But don't say FOIL. It's not the FOIL method. You can distribute. You can either do the triple distributive property, work from left to right, or the double distributive property, work from right to left. Doesn't matter which one you do. And I wouldn't worry about that -2 right now. But, when you do your work on a test, because your homework's all off of, I didn't lost the word, Slater. You go ahead and you do it your way. We'll see what your grade is. I'm going to distribute from right to left. I'm going to X everything. And after I X everything, what else can I do? Are y'all still on your sleeping pills or something? I'm going to -3 everything. That's what I got. I got -2 times a whole bunch of stuff. What do you want to do besides not be in my room, apparently? Combine like terms is a good step. It's a good intermediate step. Some of your more ambitious people will distribute the -2 at the same time. I see an x cubed. It's like 3x squared. Maybe minus 10x minus 24. And now we're down at the bottom. What's the last and final thing to do? Distribute the -2. So -2x cubed minus 6x squared plus 20x plus 48. That's not necessarily hard, is it? No, it's not. Will you make sign mistakes? Yeah, you will. It happens. It's really not that hard. All right, what's up next? Identifying zeros and their multiplicities. Up here, did I talk about the difference between a touch and a cross in your notes? I did? Okay. So I don't remember the exact thing I had drawn. I gave it to Allison. But a touch is when you touch the x-axis. How many times did it happen? No? Did I not talk about its multiplicity?
X equals 1 and x, no, x equals 10, x equals 1 and crosses, and x equals -1 and x equals 3 are touches.
Okay. So I got to it and the bell rang. A touch happens at least twice. At least twice. T for twice, kids. It's not that hard to remember. If the thing crosses, I don't remember what yours looks like and I don't really care. That's a cross. A cross happens at least once. Anybody remember talking about that last year? We did. Even last year it was talked about for a long time. Now touches are even multiplicities. Could happen 2, 4, 6, 8, etc. times. As long as it happens at least twice. Can't happen 3. It goes 2, 4, 8, 6, 10, whatever. Your crosses are your odd multiplicities. They happen 1, 3, 5, 7, etc. And that's the deal with crosses and touches and multiplicity. All right, so we're down here. For this polynomial, list all the zeros and their multiplicities. It's not hard to do. I'm going to modify it just a little bit because there's always one that kids never really remember. I'm going to throw an X out in front of that thing. So this thing is presented to you in factored form. That's what it is, factored form. You don't have to factor it. It's just already factored for you. I rewrote it for you. How many factors are there? A factor has an X. If it has an X, it's a factor. Lindsay says there's 4. And Lindsay's right. It's not because of the exponents, because there's 4 distinct factors. They each have their own exponents too. These 2 without exponents given, what's the understood exponent? 1. Got to understand the understood. I know a couple of you don't. But you got to understand the understood. Now, this earlier we had this example. X minus 4 is created by the factor x plus 4. All right. All we did was we jumped the 4 back over, right? This little guy right here, this x, we're really saying that he equals what number? 0. because you jumped a 0 over and you'd still have an x. Now, your multiplicity comes from the exponents. So we find multiplicity by looking at the exponents. So that x equals 0. How many times did it happen? Once. I saw a finger. And I usually just abbreviate M. Multiplicity is 1. Because I really don't want to write multiplicity all day long. For one, my hands hurt because of computers. Yours will hurt one day too, far, far worse than mine, because of phones. And two, I really don't like writing. All right, what's the 0 for the factor x minus 2? X equals 2. What's its multiplicity? 1. What's our 0 for x plus 1 cubed? X equals negative 1. Multiplicity on that guy? 3. Last 0. What is it? 3. What's its multiplicity? 4. Now, if we were to look at the graph of this thing, where would you expect it to cross the x-axis? What zeros would it cross the x-axis on? 1, 2, negative 1. Why? Why would it cross the x-axis? Because they're odd. Last guy's even. What do we expect to happen at x equals 3? Touch. Well, I'll take a look at that function. Just to make sure. You can punch buttons too if you'd like. It does help. I modified it a little bit. I threw an x there. It doesn't have to be in a set of parentheses. Why I put it in Y2, I couldn't tell you. I don't really care. Doesn't matter. That's just where my cursor was. Ain't nobody got time to press the up arrow. You actually can't see your calculator draw the x equals 0 one, can you? Anybody actually see theirs draw it? I was kind of watching, but I didn't see it actually draw because it's so blasted close to the y-axis. There is a crossing here. It just happens to be so steep you can't see it escape the y-axis. But we have a cross there, a cross there, a cross there, and a touch there. It behaved as expected. And if you have anybody have a color edition? Does yours show where it crosses the y-axis? Yeah. That's one nice thing about the color editions. You can see stuff drawn. So that was simple enough. What else we got left? Graphing using intercepts. So we're supposed to graph this little thing, x times x minus 3 squared. All right, so we have this factor, x. What's at 0? If that's the factor, what's the 0? 0 is at what? X equals 0. We also have a factor x minus 3 squared. Where's our 0? Three. Let's see here. Did we talk about power functions? We did talk about power functions, didn't we? Yes, we did. The power function for this thing is y equals x cubed. Anybody know how I came up with the idea of that being the power function? To form a power function, you remove the constants. So this thing becomes f of x equals x times x squared. And that's my x cubed. Now, the power function tells me about the end behavior. Because I did something a long time ago called memorization. I did it. I don't know if you did it. I know how this thing starts its day and how it stops its day. Y equals x cubed. You look at it on a graph. Heck, you guys had to memorize the mother function for y equals x cubed. How does y equals x cubed start its day? High, low, in the middle, under a bridge. What's it doing? Low. Starts low, ends high. So I know this graph is going to start down here and it's going to end up here. Now it does say graph it using intercepts, but that's not the whole story. What you're supposed to do if you're curious about, if you care about this stuff one bit whatsoever, is you're just supposed to make a small table. And that's the idea. Make a small table with the missing points. You don't have to do a whole lot. I would just plug in a -1, a 1, a 2, and a 4. And behavior tells me the rest of it. Just kind of fill in what's missing around those X-intercepts. I'm just going to use a storage feature. Take a -1, STOX. Again, if you don't know what I'm doing with storage features, because last year when I did it, you didn't play along, and this year, you're not playing along. STO is to the immediate left of the 1 and the 4. So -1, STOX. Got a little bit of a glare there. And I believe she goes x parentheses x minus 3 squared. -16. If you were to visualize plotting that point in your head, is that expected? Start slow, right? All right, repeat 1 STOX. Now, do you have to retype x times x minus 3 squared? No. How do you pull it back up? Second enter, second enter. Second enter, second enter. 4. 2 STOX. Again, store is to the left of the 1 and 4. Second enter, second enter. 2. And lastly, a 4. Do you expect that 4 to be a nice, tall, high value or a low value? Expect it to be high because of end behavior. Actually, it wasn't too high. It was 4. Kind of interesting that it was 4. But end behavior will take care of the rest. So back 1 down 16 is low like I anticipated. 1, 4, that's not too high. 2, 2. There's a 0. And then 4, 4. All you got to do is connect your dots. They got to make sense. You just connect it from left to right. So it comes up from negative 16, passes through. Right there, that was a cross, wasn't it? How many times did that 0 happen? Once. That's a cross. Bounce off, come down. There's an X-intercept. What was the exponent on that x minus 3? Squared. Are we going to cross or touch? Touch. So we just bounce off of it. Now after this point, I'm not going to add anything to my table. What do you expect it to do? Keep going up. Rules of end behavior. It just keeps going up for all the rest of its life. There's a nice quick graph. It wasn't that hard to do. Any questions on it? I realize graphing's not a whole lot of fun. It's really not hard though. Next up in your note is a theorem called turning points. I guess we need to define a turning point. I'm going to make it as simple as possible. It is where a graph turns. Hence the name turning point. Mathematical definition is where f of x goes from increasing to decreasing or from decreasing to increasing. Now this little graph we have in front of us has 2 turning points. One there, one there. Because it's literally turning. Call that TP1. We'll call that TP2. The one we just graphed, how many turning points did it have? 2. Right? One there, one there. Did we graph any other ones? I don't think we did. Other than that freehand one I did. Okay, so it had 2 turning points. This thing had 2 turning points. What was the power function? X cubed. Now that's exactly what turning point theorem says. That a function is of at least degree. Actually, I'll rewrite it a different way than that. I don't want to write it that way. A function, x to the n, has at most n minus 1 turning points. So our power function for that previous example that we graphed by hand was x cubed. It had at most 2 turning points. That's what it tended to have. Most of the time, it works that well quite nice. Most times if you see x to the 4th, you'll see 3 turning points. If you see x to the 5th, you'll see 4. But the wording here is at most, which means you can have less. A 5th degree polynomial could have only 1 turning point. It's not very possible. All right, that's turning point theorem. Moving on down to the bottom, identifying the graph of a polynomial function. Which of the graphs in figure 16 could be the graph of a polynomial function? For those that could, list the zeros and state the least degree the polynomial can have. For those that could not, say why not. Well, I don't think I've talked about it in your notes here yet. You're kind of supposed to remember this, but polynomials have smooth curves. That's what they have. Smooth curves, and you never pick up your pencil. If you got to stop, it's not a polynomial, unless you're stopping to think about crossing or touching when you're drawing. You don't pick up your pencil and leave a gap. Let's go ahead. I'm going to label these A, B, C, and D. Is A a polynomial? Nope. Why not? You had to jump. You got that gap in there. Is B a polynomial? Yeah. B is a polynomial. It's a polynomial. How many turning points does it have? There's 2 turning points. Is it at least degree what? Cubed. Now there's actually more you know about this thing. You know about its end behavior too. Based on its end behavior, is it a positive x cubed or a negative x cubed? Negative, that's right. Is C a polynomial? No. Polynomials are not pointy. You can stab your eye out with it, it is not a polynomial. Is D a polynomial? Yeah. It is a polynomial. How many turning points you see? 3. See 1, 2, 3. 3 turning points, which means it's at least degree what? At least what? 4. Is at least x degree to the 4th because it had 3 turning points. You know anything about the sign on it? Is it positive x to the 4th or negative x to the 4th? I can't hear you. It's the masks. I think I heard negative. I'm also like partially deaf in my left ear. It's an inherited trait. So by end behavior, it is negative x to the 4th. Because it starts low and ends low. We just did this stuff in Algebra 2 last week. One of the kids said his dad was kind of like an x to the 4th because he starts his day high and he ends his day high. No, I thought it was hilarious, and I know his dad, and it's pretty true. He said there's some stuff in the middle, but it's usually on the up and up. I thought it was funny. Y'all little Puritans apparently do not. Enjoy your squash. All right, which of the graphs in figure 18 could be this guy? This is called analyzing, kids. What do you know about it? Just look at it. Tell me some stuff you know about it before you ever look at the graphs. How many turning points? I think Lindsay said 3. The wording is at most 3 turning points. How'd you know that? x to the fourth. We got that from x to the fourth. That leading piece of the polynomial. Anything else you know? It's actually pretty obvious, but you may not see it till I tell you what it is. Do I know what the y-intercept is? There's a y-intercept at -6. You also know something about its end behavior. How's x to the fourth going to start its day? High. How's it going to end its day? High. End behavior is high, high. I believe, just glancing at it, there's actually another thing. It's called Descartes' rule of signs, or sign change. Let's see here. We go from positive to negative, but that doesn't actually apply here. That would say we know it crosses the x-axis at least one time. But anyways, you don't know about that rule, and probably won't teach you about that rule because it's absolutely pointless. So, could it be example D? Nope. 1, 2, 3, 4, 5. This guy has 5 turning points. Could it be that guy? No, because it's at most 3, right? Not that guy. So we're stuck between A and B. Both of them fit the model with the exception of one little detail. Which one is it, A or B? It's B. Why B? There you go. The y-intercept is negative. Over here, the y-intercept is positive. We didn't figure out the y-intercept was -6. I'm sure there's a couple of you wondering how they knew what the y-intercept was. Find a y-intercept, you let x be what? 0. Put a 0 in for all those x's. The only thing left is -6. What you got?
I don't really know how you can find out what the turn point. Like, how do you know when turn points are?
Where it turns. See this guy right here? Oh, you go to the leading exponent. Take away 1.
Every time?
Every time. There's a 7, you got at most 6. Or you can Google it on your phone, right, Kelly? I'm just trying to keep you all from having arthritis when you're older. I'm not trying to be mean. Man, these notes don't stop. Okay, thankfully this is all one big page. And there's way too much notes there. So let's do the one on the bottom. Your textbook likes to use the words analyze as a nicer way of saying graph. I don't know why they do that. If you see anything say analyze, it means graph. That's all it means. So we're going to graph this thing. Where are your zeros? 4 and -1, yes. Anything else? 0. 4 and -1 are odd multiplicity. Are they going to cross or touch? Those are crosses. 0 happens how many times? Twice. Multiplicity is 2 because the exponent's 2. That's going to be called a touch. Your power function, where you get your end behavior, is x squared times x times x. We just throw away the constants. So what's your power function? X to the fourth. How does x to the fourth start and stop? Starts high, ends high. We know when you talk about end behavior, you know the bulk of the graph. You really do. You just got to find the little stuff in the middle near the origin. Let's see here. Turning points. Power function's x to the fourth. At most, how many? Doesn't mean there will be 3, but the wording is at most 3. There's a whole bunch of steps there. Blah, 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 blah. Nobody cares. That's really all you need to know. We have a 0 at 0. That'll be a crossing point. We have a 0 at 4. 1, 2, 3, 4. And we have a 0 at -1. So you plot your zeros and you make a small table, kids. That's all you do. You plot your zeros and you make a small table. It's not the hardest skill in the world. Now, what are some numbers you might be curious about? -1 is not something I need to worry about. -2, yes. Why didn't I have to worry about -1? I already knew it. Maybe 1, 2, 3, and maybe 5. Just stuff in the middle. Just find the stuff missing. That's all you got to do. You already know how it's going to start and stop. When you plug in that -2, do you expect a rather large y value? Yeah, you expect something above 0 anyways, because it's supposed to go high. So -2 STOX again, and then I type in the equation as written. Zoom out for you. $24, an expected value. Rinse and repeat. See, plugging in numbers isn't a special Olympic event, kids. It just takes a few seconds. Some of y'all still hunting and pecking on a calculator. Like, y'all must be horrible typers. Only you had a touchpad like your phone. All right, so -2, -24. That's, off the grid. That's expected. Now we're going to come up to this guy right here. Are we going to cross it or touch it? That x equals -1, was it a cross or a touch? It was a cross. It's going to go up some, and then what's it got to do? It has to come back down. It's x equals 0. X equals 0, is that a cross or a touch? That's a touch. It's going to have to bounce up. Now what's kind of funny here is that 1 had a value of -6, didn't it? Oh man, why did I start at -24? I did, didn't I? We talked about end behavior, now what did I do? I ignored it completely. For some reason I saw -2, -24. Another reason why you shouldn't use a pen to do math. This thing started way up top. You had to cross through, run into that guy, and that guy is a touch. -1, +1 had a y value of -6. And it keeps falling for a while, doesn't it? Yeah, it just falls and falls and falls. Like at 3, it's -36. It just falls and falls and falls. Then it turns right back around and it goes for that 4. And at 5, that thing is shot straight up to a very high value. So it looks a little something like that. I don't know exactly what's going on here. I don't know exactly what's going on there, but I'm pretty close. How many turning points does our diagram have? 3. It followed turning point theorem. Let's see, the last thing we're going to do is something in a calculator. A cubic function of best fit. The data in this table represents the weekly cost of printing 1,000 textbooks. We're not going to worry about drawing a scatter diagram because, to be quite honest with you, it tells you what you need to do when you do this stuff. It'll say cubic, quadratic, whatever. Using graphing utility, find the cubic function of best fit. Now, how are we going to put that table into a calculator? It's not the first time we've done this. Stat what? Stat edit. Stat edit. It's pretty obvious. I mean, you put the first column in the first column, you put the second column in the second column. Like, you don't have to sit here and think about what you're supposed to do. About the only way you and I would disagree on anything on this is if you make a typo or I make a typo. So I'm checking mine to make sure it's put in right. And if you can write a line of best fit, most of you could on your last test, and if you can write a quadratic of best fit, most of you could on your last test, then you can do a cubic of best fit. Very simply. Now the line reg and the quad reg are both under stat calc. Where's cubic reg going to be? Not somewhere else, is it? It's going to be in the same exact drawer. Stat calc. It's telling you if you can read cubic reg, cubic regression. So what number? 6. It amazes me every year the number of kids that miss calculator problems. This one I have to scroll down to calculate. And all you do is you put A, B, C, and D exactly where they belong in a nice little form that it gives you, kids. It's not hard to do. It looks like your bell's going to ring a little bit. So there you go. You should already have your homework. Guess else you don't. You're probably out the day I went over this. Homework's 5-1. You don't have to have extras. Tomorrow we'll probably do 5-2. Well, we'll talk about your project. That needs to be talked about. Go enjoy your day and try and learn some. Yeah, that's rational functions. Yeah. We'll talk about the project.